Karen Tucker from the Churchill Club. Thank you for coming out for the program, which is called A Dive into Deep Learning. This Churchill Club session will explore trends in the exciting and promising world of deep learning, how it is being applied in a variety of industries, challenges, and the implications for innovation yet to come. Here to lend their perspectives, we have a very distinguished group of speakers. Browne, co-founder and head of product at Bonsai. Alisa Choong, EVP Technical and Competitive IT, Tacit at Shell. Jeremy Howard, co-founder of Fast.ai and also a distinguished research scientist at USF and faculty at Singularity. And Todd Mostak, CEO at MapD. And leading them in conversation is McHugh, VP and GM at Nvidia. After their onstage discussion, we will be offering some breakout discussions that are led by some of our speakers, as well as lunch. So please stick around and participate in those if you can. There are some pages on your seats that explain a little bit how that works. We would greatly appreciate your participation so that we can gather insights from you as well. We very much appreciate our partners, Shell first, for instigating this event and topic, and also Nvidia, especially McHugh, because he was invaluable in configuring the content for the program. And then last, but certainly very importantly, very grateful to Skadden for opening their doors for this wonderful conference center for our event this morning. Churchill Club is a nonprofit business and technology forum operating in the Bay Area for over 3 decades. And we present up to 30 programs each year in support of people like you who are working to advance innovation and economic growth, as well as social good. We try to choose topics that are ripe with opportunity, that are not already over-discussed. We try to surface new insights in these discussions. We always ask our speakers to share fresh information and never to pitch or promote or position. We are member-supported. We invite others in the audience to consider joining us. We would love to welcome you. If you're tweeting, please use the hashtag Churchill Club, and you will find other Twitter information in your bulletins. And with that, let's welcome Jim and our speakers to get our discussion started. Thank you.
All right, so I think we're going to have a great conversation today. We do have a great panel. And let me just kick off by setting context. We all know that machine learning and AI has been around for a while, right? But it's actually accelerating so much faster. A lot of American companies, a lot of global companies have been told for the last 5-6 years that they be digital companies. We've been talking about some of the challenges of, oh my God, I've been focused on big data and analytics for the last 5 years. Now you tell me I have to do AI. Why? Well, frankly, it's just because it's accelerating so much faster. We're lucky to have so much data coming in. Right? This is the year we're going to cross zettabytes. And because of that, it's allowing us to do things we couldn't do before. But we can do that also because we have the computational power to do that. We have the new methods of going about it. Deep learning is not new. It was out of favor for years. Right? A lot of people know that if you worked in it, you were the bad guys. You were trying to do something different. But now, ever since friends like Alex Krzyzewski and Andrew Yang and others put a lot of weight behind it, it's everywhere. Google, Facebook, Baidu, Tencent, Microsoft, all have bought 100% into it. You guys have AI in your life every day. It's there. It's influencing a lot of the things you do with consumers. And what's great about that, just like in the old days of web services, what we learn our consumer world eventually influences our business world. So that's the trend we're going through right now. There's a lot of examples. Self-driving cars. We collect the data there. We can put cars down the road. We collect data. We can actually simulate the data for self-driving cars. Medical. Take all the medical research information that's in publications, etc. It's amazing combining that with AI, what doctors can do. They can detect diseases. They can actually take any CT scan and tell you what your bone density is at a very high rate. Also, we're looking into robots. Think about it. All cars is the first AI robot, right? And manufacturing, if you ever make a trip to Japan, which I did have luck to do this year, what's going on in personal assistance because that aging population is incredible, right? Even up here in Berkeley, we have the Berkeley robot for the elimination of tedious tasks, otherwise known as Brett. Brett has gone through incredible improvements in the last year. He started off by just trying to stand. The goal when Brett was trying to stand was get your head as high as possible. Not someone programmed stand when I raise my hand or stand when I push this button. No, they gave him a goal, and he learned what he needs. So, with that setup, today we're all going to learn like humans learn. We're going to actually have an interactive component. I'm going to encourage a lot of interactions with the audience. When you do, I will ask that you introduce yourselves, tell us what's something you're from, help set the context. We know who you're talking to up here. We'd like to know who we're talking to. So with that, Jeremy, let's start with you. You're spending a lot of time teaching people about deep learning and AI and doing courses and making it accessible. What are the things that you do pretty well?
Sure. Well, my collaborator Rachel and I at fast.ai are entirely focused on deep learning, both building the tools to make it more accessible and also building the educational content so that anybody can use it. We're extremely interested in bringing it into the enterprise. I spent the first 10 years of my working life in management consulting, and I know that there's a lot of smart, committed people who have significant resources at their disposal to solve significant problems, and most of them, in my experience, didn't know how to code, and certainly weren't in a position to, go and start doing the linear algebra and whatever else to build their own deep learning models. So I think my interest is in, first of all, explaining to people why deep learning is important, and then trying to help them understand how they can utilize it in whatever they're doing. So, for example, prior to fast.ai, I spent 2 years building the first deep learning for medicine company called Analytic, where we developed systems mainly focused on radiology, for example, significantly increasing the accuracy and how early stage you can detect malignant cancer.
Awesome. So let's go to the position of Shell. Because you are a company, right? We're all coming to you and telling you AI is going to be so wonderful. What are the things that go through your head when you hear about this?
Let's start with Shell. Shell is an integrated oil and gas company. Why is that important? Integrated means that we do it from upstream all the way to downstream. We start by doing what we do best, go under the surface, look for where's the reserve. And why are we doing it? The thing is that the world's population is growing, without a doubt of it. The need for energy is growing as we go more into urbanization. And it's a way of how we can ensure a better world and a better future for every population in the world. So those are what is very important. And once we have done that, we produce it, then we have to distribute it, we have to refine it, then we have to get it to your homes and get it to your cars. So that's the whole thing. So when we looked at digitalization as an example, my team basically works on two things. That's why it's called technical and competitive IT. So the digitalization agenda is with me in terms of the selection of the IT technology and how it can be used in the whole supply chain, and downstream as well as upstream, and how it can be replicated. The second part is that we also develop technology using market standard products and do our wrapper around it to make sure that those are intellectual property. And that differentiates us and gave us a door when we go into every single country. Because the major resource holder look for company that comes in with technology. So innovation and technology is very big in an oil and gas company. Shell, as an example, in 2015 spent $1 billion in research and development in this. Going forward, digitalization is also going to be quite key, and we all know that very well. We started, like you say, in the consumer world, looking at our consumers, analytics around it, doing campaigns and packages around that. But very soon, we are now looking at a world that, we have. What we have is lots of data, be it all the data that we have in the subsurface. How do we visualize that, and the data we have in monitoring all our operations over. We have got 5,000 critical rotating equipment that we looked at a central location. Remember, what I'm saying is only 5,000 critical rotating. Can you imagine how much other equipments I have there that's not critical, but there's still quite a lot of opportunity. So for us to start advanced analytics, it's quite natural we also want to do deep machine learning. We also are in a company where you have experts. Experts are due to pure hard work of doing, of being out on the field. But in the new generation, we don't have expert who is going to be there for 20, 30 years. So how do you pass that knowledge on from the current generation to the next generation? And what can you do going forward on that? So basically, it's about keeping people safe. That is very important, because the less people you send out off-site, the people are safer. Giving them a better working environment, giving them expert help when they are on-site as well as off-site. So those are very key objectives that we are looking at, and also looking at how we can transform the workforce of 150,000 people, if not more than that. So, and making sure that regardless where you operate in the world, as a global organization, they have the consistent experience. So that is also very key to us.
Can you just give us a scope of the amount of data that you're working with? I mean, just from exploration or data from your stations or data from refineries to interactions, there must be mind-blowing.
I only know of one. Every time Rob Eppinghar is my seismic expert here, he says that every time he goes out and he crawl a data, that means crawl a certain area in a particular oil field, just looking at data, I think it's a day is 1 terabyte. It's not anything more than that. So that is just a day. And for us to process seismic data, you're looking at data for 10 years, because you're looking at trends. The earth moved, the earth, how the composition of the earth and the materials all are different. So it's not looking at 1 or 2 years data, you're looking at historical data. Same thing, when we do production, you're into asset that is about 100 years old. So again, if you say that instead of digging a new well, continue with the current well. So basically, you're looking at data that is about 100 years old. So we are one company, or should I say oil and gas is one company that's very good at capturing data, extremely good. But now is our opportunity with what's available to really how to enhance it and use it.
Shell's an interesting example of the kind of enterprise that definitely needs to be looking at deep learning and related technologies. I was lucky enough to be invited to be the only outsider at Shell's. I think it was their first International Analytics Symposium 2 or 3 years ago. And I was amazed to see, person after person present about totally different areas of the company. One person, for example, was a data scientist who had spent 6 months on an oil rig. Yes. And like every day, the manager of the rig said they found something new to optimize. So this is like why it's so important, I think, that we don't focus on getting kind of machine learning PhDs and put them in the enterprise, but take the people who already understand the business in the enterprise and give them the tools and skills they need to use this technology.
Absolutely. So Todd, let's jump over to you, because you know a little bit about processing large amounts of data and visualizing it. When you're engaging with customers and they've had tools that they've been using for a long time or whatever they've been focused with, how much of a shift does it happen when they can start interacting and exploring data differently? What have you found?
Yeah, so I think what's interesting right now is we're in this period of intense technological change, and yet organizations are still stuck in a past 10 or 20 years ago. And people are all talking about, hey, let's do big data, let's do big data analytics. And they're going through the motions, getting their data lake, which is turning into a sort of graveyard for dead data sets. And, people talk a big game, but I think people are just starting to think about what does it actually mean to get value out of this data. And so as excited as we are about deep learning, and we really are excited, we also feel that there's more basic steps that organizations need to go through. Simply getting visibility into data sets. So our startup, MapD, is a GPU database and visual analytics platform. And using these GPUs, which are also, of course, amazing for deep learning because they have such prodigious computational throughput, also makes them very good for database operations and basic analytics. And so just getting that basic visibility where people can take multi-billion row data sets and slice and dice them in real time is kind of the first aha moment of people actually getting value from their data and seeing what's going on. And then I think from there you can do a lot more advanced things like machine learning. So I think we have a long way to go, and a lot of it is education. I like what you said, Jeremy, about...
Although I would rather see people do these things in parallel. I think if you're doing deep learning, because I did a lot of work in OLAP for a long time, which I know MapD is really well placed for accelerating. The deep learning can, and other machine learning approaches like random forests for structured data, can very quickly tell you which parts of your data are the most interesting, and that can really help you to then use a system like MapD to then do visualizations of the stuff that the more automated systems told you to focus on, particularly if you have a data graveyard which you don't necessarily know where to look first.
One thing I find fascinating is the wide applicability of AI technology. On the one hand, you have these analysis tasks. I have a lot of data. I want to understand that, examine that, look into it. But on another end of the spectrum, we have things like self-driving cars, right? So we have automation, we have robotics. In the middle somewhere, we have things that are normal, like prediction, like I give an image and it tells me what's in it. So I think one thing that's fascinating is not only are we accelerating our ability to understand and examine data, but we're also getting better and better at automating, better and better at creating predictions, things like this.
So when you're engaging, and you're going to go in and talk to the developer who's probably was working in one sphere of the industry and technology, and now he's been ordained to jump in and start working on AI, what are the first steps to usually engage with them?
Yeah, so I mean, obviously, finding out where your data is, making sure it's clean, making sure it's structured is important. Setting clear goals about what you want to learn or automate, also extraordinarily important. There are a couple interesting things there. One was touched on already, and that's expertise. I think often a lot of data scientists come from a statistics background. They mentally enter and they say, just let the data speak for itself. But the truth is, practically, if you're really going to build a model and you're really going to make things work, the expertise matters. Knowledge that's in that domain matters a lot. It decides the features of the model with more traditional frameworks. In Bonsai's framework, it's in our platform, it's something that's like a core component of what you model and what you describe. The other thing I would note that's fascinating, that's related to data is exploding not just in, you have a bunch of devices and it's being collected, but it's in the simulators, you said, before. We see in like robotics or in self-driving cars that first they're training in simulation and then they're training with the real reported road data. And data is being generated in various and sundry ways. Some of it exists across organizations already. Some of it is being made per minute, per millisecond.
I don't know if everybody realizes that, but augmented reality is going to influence how we look at data. It's going to data that we're missing, we can actually create. And I was thinking about that actually when you were talking about how you're going to train that next generation. Augmented reality also will come into a place there.
Just before we move there, could I just respond to one issue that Kim mentioned, which is the role of the expert? I think the role of the expert in setting up what's the business goal we're trying to achieve or optimize is vitally important. On the other hand, I think the role of the expert in deciding how to clean and structure and engineer the data is something to be extremely careful of. I spent quite a few years at a company called Kaggle, which has about 500,000 data scientists and runs machine learning competitions. And in nearly every one, the winning entries turn out to be ones where all of the data structuring ended up getting done automatically by the algorithm, and all of the previous best practices based on hand-engineered features turned out to be less good. And this is really what we've learned from deep learning.
So let me interject there. So was the problem that there was experts involved, or was it the path they took to come to that outcome?
The problem was the difference between hand-engineered filters and hand-engineered features versus automatically developed ones using, in particular using deep learning. So what I've experienced personally is very, very often when I get a data set from an organization, it's already been filtered and cleaned to the point that everything interesting is gone. Whereas if you give me actual raw data, then I can do a lot more with it.
So that's an interesting point. I mean,
I think, yeah, to build on that point, there is also something we are looking at because data is always clean, data is facts. The other part we have to lay on top of it is the human psychology and the emotions. If someone is to drive on that same road every day, the data is very clean, okay? But why on that day he's driving the same road, it caused him to roll over and lost his life. So that has nothing, sometimes it's not the data.
because it wasn't an autonomous driving vehicle, that's why.
Yeah, but again, if you think about it, that's the part that we also challenge a lot with when you have a lot of clean, structured data.
Let me put a scenario out there. There's a scenario where we've been handcuffing our data scientists and our data engineers for years. Because we've been putting challenges out to them, and we've been saying, we need this answer. And they've been doing it with tools and mechanisms where they can only get statistically, directionally correct. And how many times have you heard this? It's not 100% conclusive, but directionally, I think we're going in the right area, right? And so because we've spent years limiting that, and if that's the data that you're going, that it's been statistically, directionally correct, and then you start training off that, it's possible, highly likely, that you're training with the wrong data set. I think that's what, Jeremy, you were alluding to.
Well, I mean, it's in fact the kind of previous statistical-based approaches, I think, are what's driving this over-cleaning, or one of the things. So if you're not going to give me the raw data, what are you going to give me? It's probably going to be like discretized, grouped data, such that a traditional statistical tool could look at like an over table and say, with a p-value of 0.05, this is less than this. What this misses is that all modern machine learning techniques can handle all the variables all at once and find deeper structure. And that means by doing it that way, it removes all of the noise out of the data. So you don't need to discretize it and group it. You can get something with a p-value of 0.0000001 directly from the raw data. So I think it's, yeah, don't filter out the noise. Like the car that rolled over, it didn't have a lower speed because it's an outlier. It had a lower speed because it had a car crash. So don't group it into average speed per road segment. You know, give me the every car, every road segment, every speed.
I don't think that it's the job of the expert is not to predict data.
Todd,
In fact,
I
that's
can't
one
hear
of
you.
Reach back here.
Actually, the beauty, of course, with deep learning is that it handles all this data, and the more data it has, the better. Well, it has a better chance at getting a good outcome. But the way you approach the problem, the way the problem is decomposed, the way it's debugged, the different data sources that are brought in to make the data set generalizable, these are all really important roles for the expert in the process.
Are we, though, to the point where you can just naively dump your data in, all the raw data without any kind of feature engineering? Even in a convolutional net, you're doing some kind of feature engineering at the start with the convolutions you do. And if you just threw the raw images in, you're not going to get very
No,
good
you just throw the
results.
raw images in. The convolutions are totally automated, what's done there. So this is the big change. We're absolutely at that place. So when I went into Sprint a couple of years ago, I had a 20-day project. I spent the first 10 days talking to the senior execs of every part of the company to say, what are your biggest strategic goals? So my first job was figure out what problem to solve. And the second 10 days was grabbing every piece of data from every data. There was no curation. It was just grab the whole thing, stick it all together, chuck it around in forest, and find the 9 things which turned out to solve the problem. And we ended up with $1 billion worth of solution.
One of the things we found, this is not so much on the analysis side, but in reinforcement learning and doing automation and simulation, is that there's so much data and the goals so sparse that if we're just to train purely without some sort of model of what's going on in this, it can't be solved in a reasonable amount of time. So I think that modeling will continue to exist. But what is interesting, it is true that a lot of problems that used to require lots of modeling don't anymore. But that also means now we can go tackle harder, more complex problems using those techniques.
I think let's think about this. Culturally, we have people that have been curating data. If we don't do anything to understand what the data is, we have to think through, are we going to trust the outcomes? I can tell you for 100%, if you're training a car and we only drove around Palo Alto, it would learn to drive around Palo Alto. But if I took it to New York City, it would have some issues, right? So there is the data set that's going in is going to be what the neural net's learning off of, and then you have to figure out what's the right training to what's the right test set, and then the ability to visualize that. And you guys have some techniques of what you're talking about. You know, Todd, you guys have some techniques about what's going to give us the confidence of what's going on with the neural network, right? I personally don't have that insecurity about what's going on. I kind of trust it because I've seen it in enough factors. But there's a lot of people in the enterprise who are going to say, how do I know, right? I think in Europe this is a big problem, actually.
It's definitely a problem. Because like I say, remember, you have experts who really work on it on hands, and that is what's trusted. How do you replace the gut in you?
So
that's
culturally,
where it goes on that
culturally, let's go through this. How do we get the experts to feel comfortable with the new approach, giving them tools that augment what's going on with the neural networks and everything that us purists who believe in AI through and through, how do we give them that?
I mean, I think explainability is key. And you know, there's some research on that up at Berkeley. There's techniques like Line as well. That's a core part of the thing we work on inside Bonsai's platform. Going forward, if we're to trust these algorithms to be able to drive a car, to even make predictions with money or something like this, like we need a way to log why that decision happened, be able to diagnose what went wrong, be able to go back and fix it. And really for us thinking about the developer space, you know, one big part is a drastic increase in ease of use so that you don't need a PhD in stats to use the technology. But another part is explainability, it's debuggability. A programmer expects to be able to sit down with something and be able to debug it, to be able to fix it when it went wrong.
And to be clear, the way that one would expect to debug that self-driving vehicle would not be to open up the neural net, look at the coefficient of the 391 millionth parameter, and decide it was a little too high.
Yes.
The way we debug these systems, highly predictive systems, is the same way that we get confidence in a human. You know, human learning and machine learning are moving closer and closer together. So the explainability comes from asking the model questions. So, for example, here is a complete LiDAR and video feed of a car driving around New York. There's a pedestrian about to cross. What would you do? Or understanding what's causing it to behave in particular ways. So I spent 10 years a while ago building what I think is the first company to bring simulation and optimization to the financial services industry. And to get these very conservative companies to believe these models, which we actually use to set their most basic things like their pricing. We just spent a long time giving them a simulator and letting them ask question after question after question. You know, what if we changed our rate in this market in this way? What would happen? You know, this is the way experts get comfortable. It's the same way that get comfortable with a new recruit, is to ask them questions that they know the answer to and get comfortable with the answer that comes back.
To your point, it's just not detect and take an action. You have to perceive. There has to be another component to that, right? That's where the sort of the logic behind the scenes that's coming in and making decisions.
And it is possible to decompose part of that process of perceiving and to take a look and see, oh, you know, this is the sequence of actions that I thought were appropriate for this.
What about, though, when the explanation is as important as the accuracy of the model? I think in a lot of enterprises, people are kind of afraid of neural nets. People call them black boxes, but it's really that they're very comfortable with traditional forms of regression, where they get a coefficient and they can send that to their boss and say, hey, this is correlated with this, and r squared is 0.83, and yada. And it's very simple, and it's probably not as good a model. Right. It's not going to be as predictive, but then you get a neural net, and there are, you know, potentially 1 billion parameters.
Right. And the truth is that that traditional regression approach is a disaster more often than not, because it turned out that coefficient, there are already 14 coefficients, but the 12th and the 13th were, you know, interrelated in a complex way, and actually that 12th coefficient wasn't really what you thought. It was actually saying that this 13th coefficient was slightly less than we thought, not that the 12th was really negative. There's a paper which I would highly recommend everybody. The most important paper of the last 30 years in data science. It's by one of the folks at Berkeley, who you mentioned, Leo Breiman, who invented the random forest and the most widely used classification tree. He's got a paper called The Two Cultures of Statistics, in which he talks about the idea that a very complex, highly predictive model can give you a lot more insight and comfort than a less predictive but more simple regression model. Because its accuracy means that when you ask a question, the answers you get back will be correct. And he shows all kinds of ways, all kinds of clever questions you can ask these black box models to get a lot of in-depth insight from them.
That's cool.
Go ahead. So are we ready to take a question or two from the audience, and we'll come back to moderate back here, and then we'll go to the audience? Is everybody okay with that? So I have somebody with a mic nearby, so we can all hear the question.
I also speak loud, so. Oh, sorry.
So remember, when you ask a question, please introduce yourself, company, so we all have the context of the question. So we got one over here.
Hi, I'm Joe, CEO of General Symbol. We use 3D graphics and machine learning to create three-dimensional scenes based off of descriptions. So I'm actually just curious about this because you guys were talking about some of the psychology behind decision-making fueled by machine learning-empowered applications. And I think a lot about when people who are actually in the field, the people who are the end decision makers, are deploying deep learning-powered applications and are forced to confront an emergency situation. So classically, you see a lot of failure cases in deployment of artificial intelligence at the point of emergency when people fall into cognitive tunneling, where they start over-focusing on things, and when the situation changes and the artificial intelligence is no longer relevant or contextually appropriate for the circumstance, people tend to freeze up and fail. So I think that might be where a lot of really serious risk management is focused. So how do we mitigate that?
A concrete example of that?
Yeah, sure. So a concrete example of that is like Eastern Airlines Flight 1011. So Flight 1011 happened because they were in autopilot mode and there was a failure in the pico tubes, which were measuring airspeed. And that failure led to them losing ability to read out data around certain parameters of the flight. And then the pilots leaving autopilot mode, being thrown into an emergency situation, became overly fearful and rigid in their thinking, which led them to focus on the wrong things and focus on the wrong data being outputted automatically by their computerized systems in the plane, and that led them to crash into the Everglades. So that is an example of cognitive tunneling.
Okay. So I think what we're dealing there's first. Can you hear me? Does my mic work? Okay. So let's break that down, and we can address it in the panel. The first was the detection, right? So there's an error, it discovers something, action. Then there's the perception, what am I going to do, right? And then there's the action itself. So, the question is, where did the breakdown? You're saying it broke down from perception to action.
Yes.
And to follow through your example, the action was taken by the pilots, right? So I would say, and I'm going to put this out there as a chance to open it up to us, is there somewhere where you've been surprised where artificial intelligence has made the decision most humans wouldn't make and it was the right one? I think the most famous version of that is the game of Go, AlphaGo, when move number 37, they took the center square and all the commentators said, oh, it's a computer glitch, right? If it was a computer glitch and you thought it was an emergency, you might have turned off the computer and finished the game. But it turned out to be the most brilliant move that anyone has ever seen, and it was pretty much game over. The Go champion, who's won year after year after year and never could explain why he won, he just had an intuitive gut feeling, was awestruck. He found himself on the defensive so fast. So I'm just putting it out there. There are times where a cultural thing we're going to have to go through here. Detection happens. We decide to pull off the trust. Most airplanes, I think like 15 minutes out of the entire flight are flown under autopilot, right? So now here's the question. Where do we make that decision? So I'm posing that as a question.
Yeah, it's an interesting question about where do humans sit in the loop, and I think the long-term trend has been that they're moving higher and higher and away from the loop, being directly in the loop. It's very important. While we don't necessarily trust these machines or these algorithms, it's very important to improve that display. And you're right. There's lots of human factors problems there, and they're not solved. It will continue to be important to display information to the users that are sitting in that loop, but I do imagine a future not too distant from now where humans will be sort of above that loop and commanding down on the plane instead of, maybe not with aircraft because of the regulation, but with a car, you're giving it a high-level command, go to this location, and then it's following through. And then if you disagree with how it's going to the location, you give it feedback, and it makes decisions about how to compensate.
I think your Go example is really interesting. I think the example you mentioned of the plane is a fascinating one, but I also feel it comes up and again, and it's not nearly as common a situation to most people's actual enterprise situation as the Go example, where it's like, our systems are suggesting that we reprice New Jersey in this way. That obviously sounds stupid. Let's ignore it. And that's for most of the last 30 years, if a model tells you something that sounds stupid, it has meant that the model's stupid, and a lot of people don't trust models for that reason. The difference now is that, for example, in that Go example, DeepMind actually has lots of tools to provide explainability of the Monte Carlo search tree and of the convolutional neural net, such that we didn't get to see them. They could figure out straight away why it was going that route because they have these tools. Unfortunately, almost no researchers are working on that tooling right now. We know it's possible. Some people have done little bits of it, but it's a bizarrely, totally ignored area of actually creating things that take deep neural networks and show us the incredible amount of information that we can actually draw. But I've seen some of the things that DeepMind had, and they certainly knew right away why that was important.
We have an announcement in January you should check out.
No more product announcements. But anyway, let's take another question from the audience.
My name is Ramu Sukram. I am the CEO of a startup company called Sync. We are leveraging machine learning to assist us to do intelligent sharing and retrieval of all the content and people and events we attend with. And my question is on the size of the data set, right? For example, Jim, you mentioned about this radiology thing, right? I don't know whether I would trust the machine to read my radiology and tell me I have this cancer or not, right? I would rather have a human being who's well trained over a period of time, to assist me. So my question is, what should be the size of the data set that helps us to give us reasonable confidence in these predictive systems?
Well, I'll put two things out there. Size of the data set really depends on how well annotated it is. Really well annotated data on retinal scans, you could train a deep neural network to be more accurate than someone who's worked in the industry for years and years and years. So if it's well annotated, there's people from SAP in the audience, they have a lot of well annotated data. The amount of training they can do on a very specific thing is incredible. But the truth is, if you have a lot of data, which I think Jeremy was laying out, somewhat annotated, somewhat not, it's going to find patterns that it's going to take a doctor to do for a long time. We live in the U.S. HIPAA will require these things to be advisories, assistance to the doctor, and we'll gain confidence through that level. But no, I wouldn't discount that result at all.
I built that radiology system, so I can tell you exactly what we use in terms of data. Can you hear me now?
Yes.
So I built that radiology system, and I can tell you what we used. It was a surprisingly small data set. We had 1,000 examples of people with cancer and 5,000 examples of people who didn't have cancer. And we had almost no annotations. The only thing we knew is which quadrant of the lung was the tumor found in, if it was there. Having spent 2 years working on that problem, I can tell you I would never want a doctor to look at it. I would only want it to be looked at by a computer, and I would not want anybody to override it. I also say this as somebody who has had in my family a neuroradiologist give the wrong read on a brain CT scan. almost to disastrous effect. And I absolutely know that that would not have happened with a computer. And it was because of what you mentioned, which is it was a somewhat rare situation, which any computer would have seen that rare situation because it would have looked at the whole PAX is like the database capability, the whole PAX archive. And there's no question it would have come up. Whereas the only human at UCSF that had seen this thing was the one guy who happened to be an expert in that thing, and luckily, at just the right time, he happened to see the scan and goes, no, it's this rare thing.
Well, one thing I will note there that's interesting with the algorithms and the data set size is that the nature of the error of the algorithm when it does make an error is different than the nature of an error for a human we're looking at it, which is, in the case of these scans, I would agree. I think machines now are doing an excellent job at finding objects and images.
To be clear, we're all saying this has been trained, but I think we would all agree they've been trained. There was a good test set that wasn't part of the training set that accuracy was determined, right? So don't think people are going to just put trained cars and blindly trust it. There's going to be a test set that you're going to do, right?
This is where the government was brilliant. They stepped in and they spent a lot of money tracking a whole lot of people at high risk of cancer over a 5-year period. And so our test set was, we ended up getting cancer. And so we were able to test it against that held out sample and know for sure how comfortable it was.
Go for another question.
Hi, my name is can you hear me?
Yes.
Okay. Hi, my name is Masoud Mortazavi. I run a research lab at Huawei. I have two questions. I think two fallacies are coming out here. One of them is what I call the fallacy of the first step. It's AI has always been sort of trapped in this fallacy. The monkey has gone to the top of the tree, it will make it to the moon. Would you please address that? The second problem I'm seeing is that we should not overplay the success of AI techniques in digital worlds. So Go is a digital game. Chess is a digital game. The world is not a digital space. So would you also please address that?
Well, the first clarification is chess lost in 1997. It took till just last year that Go was able to be conquered. I think the world is becoming digital, though. I think the amount of video, the amount of data that's going on in seismic that Shell's seeing, I think the amount of information we can follow tracking patterns of networks, right? I can actually sort through and understand cyber attacks better than I ever could in the past.
Radiology has been digital.
Radiology is digital, so...
It is true in the robotics or the self-driving car domain that is interfacing with reality, and we sometimes say the world moves at 1 second per second. So, like, you know, there's in the digital world we can really speed things up, but in the real world the decisions are tracked with how they play.
I'm going to leave you to the monkey in the tree. It's yours, Jeremy.
I have no idea what that meant. So instead I'm going to follow up on your topic about the digitalization, which is sometimes things are not digitalized with terrible results. And the example I want to highlight is everything that's true and amazing about radiology is not true about pathology. So radiology is looking inside people with MRIs, CTs, X-rays. Pathology includes things like reaching in and getting a little bit of tissue from the tumor and looking at it under a microscope. The FDA has, as yet, not approved the ability to look at a digital picture of that slide, which means that we can't utilize experts elsewhere for this type of thing. And it also means we do not have the 25 years of digitized pathology scans in radiology. And even if we did, we would have no way to train the algorithms that we've done in radiology because none of it's been digitized. So sometimes the world is still analog because of kind of bloody-mindedness or stubbornness or politicking or whatever else that leads to these kind of stupid decisions. And this costs lives. You know, not being able to apply life-saving technology because people have intentionally held back the ability to digitize the data, it kind of drives me crazy. Similarly, you know, we know that if we were to combine various medical databases, and we know ways to do that safely, again, we could save many, many lives. And we choose not to because it's more convenient politics to avoid that one kind of, no lawyer ever got fired for saying no, I guess is the problem.
Mm-hmm. Right here in front. Oh, actually, sorry, in the back, and then we'll come to you.
Sanjay Marimadaya. I'm an entrepreneur. I build a deep learning solution to predict application performance at Computer Associates in our accelerator program. So the question I have is more about the use cases. Not every company is ready for a moonshot program like self-driving cars. So what are the parameters you would suggest we consider as the first project that large companies can target, from the maturity of algorithms to the impact? And I would also request if you can remove your mic and speak to it. We can hardly hear Jeremy.
All right, so why don't we start with Keen, because this is basically what you were leading to earlier, is like when people are thinking about a project, they have to change their perspective.
Yeah. So, there are usually, when we're working with companies on first projects, we identify something where it's relatively low risk. There's an expert involved. There is perhaps a data scientist involved. There's an engineer involved, and work to really bring them together and make sure they're successful within that one project. And then once we have that evidence, we move forward with something more complex or sophisticated. Really, at the end of the day, a lot of the exploration and analysis is understanding your business and what's important to it, and figuring out what is it that makes you special, and how can you bring in this technology to complement that, to enhance it, to discover something, to automate something. I don't know if that helps. It's kind of general.
What do you think about the difference between experimental, I'm just going to let this find things that I can't possibly find, or I'm setting specific goals, I'm trying to accomplish a business activity?
Well, a goal can be, I want to discover some information. I have all this data. I want to know more about it. A goal can also be, I have this process and I would like to make it work better. I have these predictions I want to make. I want to make them.
I think we are talking about enterprise here. Yeah. So a lot of enterprise do spend a significant amount of the time looking at what's the business challenge and what sort of outcome could be the possibility, and how to get to the outcome faster at the lowest possible cost. Experimental is good, but like I said, this is enterprise. Yeah. There's only a certain amount which is experimental in that sense. Important thing is what we are trying to apply in all this is how could we get to the outcome faster, and how we can save people's life and make a place better for people to work in.
I think enterprise has to be very careful, though, of their attitude to risk, because I've actually, at Singularity University, I have a lot of kind of Fortune 500 exec audiences, and for a few years now, I've been kind of preaching to them to get data-driven. As yet, I am yet to find a kind of legacy expertise-driven company that has successfully become data-driven compared to the companies which start data-driven, like your Googles or Facebooks. Increasingly, what we're finding is that a company that is born data-driven, once it comes into the space of a legacy company, and this is a risk which is kind of hard to quantify and manage, which is that by being conservative, you are dramatically increasing the probability of a company-destroying event, which is a competitor comes along and does what you do better. For example, if in oil and gas, somebody comes along and takes the seismic data and applies deep learning to it and rapidly finds fields much better than you do, and then uses similar techniques to optimize their drilling, and they end up at half the cost that you have for energy, you're in big trouble, And so I think we're at a point where the technology is moving so fast that you need to be experimenting. And the cost of experimenting is very low, as long as you're, as you describe, you keep pointing out the importance of test sets. If you invest in understanding test sets, that every exec in your company understands test sets, then you can actually do rapid experimentation with a very low risk of doing something stupid.
So
I think maybe just let me clarify, what do our interpretation of experiment mean? Experiment means basically doing things that you've never done before. Yeah. So doing an experiment of looking for a new source of energy, on how do you transport a new source of energy, how do you do it in a faster and safer manner. So those are very experimental new business models. So what we are talking about, if we can do the same thing to solve today's problem and adjacency, that to us is still the current model. So that to us is not experiment, it's driving for business goals. So R&D, research and development, is experimental, things that will take 5 to 10 years. So anything that is below that, we don't call it experimental. So again, there could be difference in clarifying what exactly the enterprise is talking about.
I think that's a great point. I think the one thing I'd mention is the huge cultural challenge that legacy businesses face. So, for example, I know in oil and gas that the vast majority of the kind of technical expertise and traditional approaches is based more on modeling. You know, there's this kind of difference between model-driven and data-driven, which is what that Browne paper I mentioned focuses on. A model-driven approach says, this is our best understanding of the fluid dynamics of this system, this is the best understanding of the geoengineering of this system, blah, 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 and let's kind of combine all these models together to create a huge simulation. And of course, no model is ever accurate, so you then go and tweak the parameters at random until it starts giving the right results. A data-driven approach ignores that whole thing in the middle and says, this is our input observed, this is our output observed, we'll just throw a machine learning box in the middle. The machine learning box will be more accurate, more predictive, easier to create, but all of that expertise that you've built internally to create, and it's not just oil and gas, this is true in finance, this is true in logistics, it's true in every big organization I've seen. You kind of have this cultural challenge that you're having to get a whole bunch of people to try to think of things in a way that they feel is extremely inelegant and unclean, you know, because you're basically throwing away all the science and replacing it with data. And I think that's challenging, but I think that's the way we're moving.
I think from the Shell perspective and Todd from the customers you're seeing, I'm 100% believing we're all going to AI at this point, right? Yeah. But there are people today who are just held back because they have data and they can't even do the correlations and see the connections between it. And so, Todd, I don't know, you probably have examples for just that, where people thought real time, by the way. And I love in our industry when we talk about real time and people say, yeah, it's about a minute, 10 seconds. That's not real time, people. That's a minute to 10 seconds. Real time is sub-seconds and interacting with it from there. So there must be examples where people can take advantage of that today.
Oh, absolutely. I think we're sitting here in Silicon Valley. We're about 5 or 10 years in the future, you know, from the rest of America, from what I've seen in big enterprises, big telcos. And people are just, you know, scrambling to even get any kind of visibility into their data. And the idea of applying deep learning is probably foreign if they've even heard of it. My question is, and I actually don't know this, so I'm asking the panel here. How far away are we from, you know, a non-data scientist being able to take a set of data and put it into, you know, a neural net or some deep learning algorithm and basically get some answer out that they can interpret that's a model? It still strikes me right now as you have to have somebody pretty trained. You know, it's kind of, I know with Bonsai, I mean, it's getting easier.
Yeah, I mean,
so an open question, yeah. Like, so somebody, say, from Verizon, and they're looking at, like, what's causing drop calls. Yeah, right now they just kind of...
So our platform at the moment, the focus is on reinforcement and supervised learning, not on unsupervised learning. So that means specifically if your problem is I have a lot of data and I want to derive insight, that's actually not something our platform focuses on.
I do have a data point for you.
But there are a lot of, tools available for that.
At the moment, unfortunately, deep learning does require some level of training. We're currently doing a crazy experiment, which is can we get people with nothing more prerequisite than 1 year of coding experience up to the point that they can build, apply, debug, and maintain deep learning neural nets in 7 weeks, 2 hours of class time a week. The answer seems to be yes. I know some of our students are in the audience, so maybe they can comment directly, but we've already seen people have posted blogs about how they've used this to look at Alzheimer's in brain scans, and how they've used this to study huge corpuses of text, and this is before the 7 weeks is even over. So I do think the ability to train the people you have in-house can be reduced to a very reasonable amount of time.
So is it not just image recognition? See, my sense is that if you want to do a ConvNet to do image recognition or image classification, yeah, there's a relatively straightforward process there. And there's already nets, there's Alexa, there's nets.
So the nature of what we're working on is to rephrase the way programmers express intelligence. So right now you spend a lot of time, figuratively speaking, working on the student. You have to think a lot about the model, what is the details of the learning operation. In our platform, you actually describe the problem. You break it down, you describe the pieces of data, their relationships to one another, and then we have an engine, kind of like a database engine, but instead focused on building deep learning models. You feed a script, a formal description of this problem to our server, and then we generate the model. So, you know, the core, our jump in ease of use with the platform really comes from moving up a level of abstraction. It's providing tools to describe a problem.
I guess my point is that, like, okay, you have image recognition, but some of the interesting things that would be really great for businesses out there are kind of involve very state-of-the-art machine learning, like recurrent nets, things like that are not cookie cutter, and I still think are an active area of very active research. I mean, all nets are, but specifically this area.
So I'm going to transition this because it is true. I mean, there's not an industry in the world that aren't buddying up with a great researcher. Jan LeCun, Facebook, Claudio Silva, baseball. Most of the automobile guys have universities they work with because we are still researching a lot. I think a lot of what we were talking about, we have an enterprise-ready AI breakout we're going to do afterwards. Let's let the audience drive our conversation a little bit more. We'll go to another question.
Hi, my name is Zvi Ackler. I'm with Optimizing Mind, and we do explainable AI, explaining from within the inside of the algorithms. My question is, how do you get the experts or the users to know, when the network has sufficiently gotten up data and so on to avoid overfitting? Well, and what I mean is that it's taking some sort of statistic from the data that you didn't really intend to. It's just a figment of the data, as opposed to really learning and understanding and picking something that's not a figment of the data set. And the problem, I think, it underlies with the explainability of the algorithm in order to be able to localize that and say, and that's associated with large data because you need large data to try to avoid this overfitting, but you don't really know when you are or not, and if you massage the data too much, you might be actually introducing stuff. So how do you plan on addressing it?
Is this the classic black box question? Or?
It's part of the black box.
I mean, I would strongly disagree with the assertion. I would say overfitting is largely a solved problem. We know if we're overfitting because the accuracy on the test set will be much less than on the training set. And in structured data, we avoid overfitting by using random forests, which are automatically regularized trees. And in deep learning, we avoid overfitting by using dropout, data augmentation, and batch normalization. So I think this is a solved problem on the whole.
I think it's a solved problem, but people have to understand how to do it correctly to solve it.
Yeah, so that'll be built into.
So yeah, I think for data scientists, there are lots of tools. I think packaging those up in such a way that a normal programmer can use them is still a tremendous
challenge.
challenge.
I'm just talking about what can be done in the research community, and the lack of actual usable tooling for normal people is a huge disappointment, I'm sure, for all of us.
All right. Let's go right here.
Hi, my name is Xiwei Zhou, Director Engineering Team in SAP Innovation Center, Silicon Valley. Most of the time working with customers, try to bring the innovation from SAP to the market. So I have two questions. The first, we talk about for example, in healthcare, the radiology image classification by machine. Actually, I have a talk with my doctor yesterday regarding my eye scan picture and how we figure out what the disease could be and so on. So So in the future, there's a lot of automation from the AI. Then how do you guys see this impact to the global economy? And how about the workforce transformation in the future in the entire industry, in the society? And the second question is, in the human being, we learn a lot. We have gut feeling. We have a lot of structured information. Also in the enterprise, we have a lot of processes and structured information that's already optimized by human being, right? In the AI, in the deep learning, we just focus on data to get data and train them to have the data to figure out what is the best way. And how do you see the combination of these two together can bring better automation or better optimization for the enterprise, for the society?
Who's the brave person to go first? I can actually comment on it, but...
Sure. In healthcare, I guess I should respond to that part. Healthcare is, by many measures, the world's largest industry right now. Healthcare kind of consists of two components. One is figuring out what's wrong with you and what to do about it, and the other is doing the thing. They're about half and half in terms of economics, and the first half is entirely data analysis. It's not how doctors do it, but it is entirely data analysis. There's going to be a huge impact of automating that piece. In the developing world, where most of the people in the world live, there's a shortage of doctors, about a 1 in 10 shortage of doctors in places like India, China, Indonesia. So this will allow billions of people to have access to modern medical diagnostics for the first time. On the other hand, there are many industries like truck driving, which are rapidly in the process of getting automated, that do not have a huge shortage of experts. In medicine, it would take, according to the World Economic Forum, 350 years to train enough doctors to meet the needs of the world. Whereas truck drivers, we're going to see a very different result, which is suddenly we're not going to need truck drivers anymore, except for very special situations. And the impact on the economy of all of those areas is that we're going to have to find new ways of handling kind of the social support of having vast groups of people who we don't need their skills anymore.
I think it's an interesting point. As we talk about self-driving cars, what it really means is the transportation industry. And transportation, shuttles, and truck driving are much larger than personal cars. Right? So it's actually, that's a great point. But it'll be safer as well when you have trucks that are driving their path and you stay on them and go from there.
Can we add a great book on this topic is Connectography?
A great book on this topic is Connectography by Greg Connor. And you had a second question was about
data and the structural information
in the system. Yeah. It's kind of interesting because slightly to the black box question, I think you gave a different version. People have emotions; they have built things up. Is that me now?
Is anybody's phone on?
No, mine's off. So when we talk about these neural networks and how understand the output of it, I think it's important to remember there's a lot of days. There's a lot of days that most of us are black boxes, right, as well. So we're not the most, we're intuitive people, but sometimes we're hard to understand as well. So I think it is an interesting way of interacting with AI, and the best example that I know that's in process is what Baidu's doing. As they're going to roll out self-driving cars, they're painting them a certain way. They're going to be putting them in certain cities so that you know that's a self-driving car coming down the road, and you'll know how to interact with it. There's going to be needing to do that. I think as we go in the enterprise, I agree. I'm with Jeremy on a lot of these things. I think we're going to be determining and getting much better insight, but we're going to have to let people know this is the insight that we got and why we have a confidence in it and build it. So there'll be these sort of how do you interact with the results of AI so that we can actually mature through the process as well. And I think the more that we can train up these young programmers who can help deliver more models and get people more comfortable with it, we'll get through that transition. But we've got a black box trying to act like a black box. Neural networks trying to act like the human brain to some degree, and it's going to take a while for them to get along. way in the back had his hand up for a while, and I kind of looked this way.
Hey, hi. I'm Shaunak, co-founder of Emma AI. We are basically a robo-advisor. We manage just under 50 million. So our AI, actually, I was curious at the initial point of conversation when you said it's like any AI or any neural net tends to give probabilistic outcomes, right? But I think that's true in real-world scenarios as well. I mean, mathematically speaking, you can't actually know, if an event is actually going to happen unless it has already happened, right? So I'm not entirely sure as to why a neural network should be held to another standard when, like, it's literally mathematically not possible. So that was my first one. My second point was more on a study that we did with CNN back in September. And CNN had asked us, and I'm bringing up the horrible events of November 8th again, but CNN had asked us to do a study on the elections. And our AI took data that goes back to April 2015. And this is all Twitter data, by the way, so it's all in the public domain. And it basically created a model of prior experience, and then it took anomalies into account. So the anomalies were, there's the horrible terror attack in Paris and Brussels earlier this year. And another anomaly event was the S&P going down 10% in the early part of this year. So both of those anomalies resulted in neutral supporters that had engaged with a tweet from Donald Trump being more proactive and taking a more proactive stance towards what Trump was saying. Now, interestingly enough, and this is the why, right, which is, I think, what we are trying to answer, is that it's not, the issue isn't what the neural network output, it's the reasoning behind it. The why in this case was that it was obviously an event as it related to, security, so domestic security was a concern, and obviously the economy. But interestingly, when you take into account the time period involved, those same people, they reverted back their stance to original moderate neutral stance, one that was less favorable to Trump after 11 days and after 4 days. Now, what that tells you is that you can measure events in respect to their time period, and obviously this is nothing new, but if you start building, and I think this is relevant for the enterprise, because in the enterprise you have a lot of data that is very text heavy. And so you need to model out the text in a way where it actually makes sense for the enterprise to invest in AI, because otherwise most enterprises are just going to be interested and they're not going to be taking any material action as it relates to the underlying business. So just throwing it out.
Will you let us get away with "we agree"?
I mean, it's a good point, though, because I thought this question, which didn't get answered, was really important, which is what can deep learning actually do right now? Is it just good for images? The answer is mainly yes, particularly if you want to use more off-the-shelf stuff. But in the last 6 months, it's achieved state-of-the-art in language processing as well. And because it's achieved state-of-the-art in language processing and, of course, speech recognition, that means that things that involve sequences, it's really, really good at. Which means I think we're going to see pretty soon that it's going to show state-of-the-art results in things like anomaly detection, in things like finding a leak in your gas line, finding a fraud in your e-commerce history, or other kinds of time series analysis of those types. There's nobody really, nobody I know of in the research community working on that right now, but I do think it's really low-hanging fruit that's going to go pretty soon.
I think one of the things that's exciting about deep learning is that we refer to it as one thing, but it's actually a bunch of things. It's a bunch of algorithms that are solving a bunch of different kinds of problems. So that's something that's exciting.
I mean, it's mainly two things. It's RNNs and CNNs, basically, and variations of the two. So CNNs being things that can look at kind of largely fixed size boxes or lines. So music, a piece of music, an image, a volume, such as a video or a radiology image, and RNNs, which are things that have sequences that have state.
And CNNs are largely under control. RNNs are
They're both dramatically improving every day. RNNs is still at the kind of... A lot of people are trying to use RNNs. RNNs can generate sequences, so you can look at a picture and create a caption, or you can take a question and generate an answer. That part of RNNs is still, to me, massively overhyped right now. Everybody's trying to build a chatbot. I doubt any of us have used a chatbot that's not shit. So that piece people are kind of working on and probably expecting far more than we have ready right now.
I actually am quite proactive. I think the chatbots are going to get a lot better.
Absolutely,
the
they will.
trees are going to get a lot better. I think there's tools now that are pretty good at listening to my intonation. If I was a sales guy on a phone, it would tell me, hey, you know, that guy got a little annoyed when you said that.
But I am shocked at how little investment companies are putting in something that will get them a lot more bang for the buck right now, which is rather than creating some robo-advisor on their e-commerce front end, why aren't they creating the thing that tells them that, drops their fraud level by half, or drops their credit issues by half, or, these are critical things involving time series, or, dramatically increases their drilling productivity. I think these are all things that RNNs probably could do right now, but I haven't seen anybody working on it.
See, I think that's going to be truly transformative for a business. The realm of the domain of things that you can apply that to.
But academics don't have access to those data sets. They don't know that these are problems that are important. So we have this big disconnect between academia and industry right now.
Okay. Questions? Right behind you, and then we'll come to you.
Hey, I'm Nima Garde. I'm in Jeremy's class, and I also have a startup that helps people make better purchasing decisions through machine learning.
So was I a liar, or some weeks of
No, yeah.
experience?
So I'm a self-taught programmer, no computer science background whatsoever, and probably have doubled the performance of our models since I've been in this class, so it's pretty easy to say that it's definitely possible.
I thought I said no commercials. What's going on
Our class,
That's good.
our class makes no profit.
That's impressive. We want this to happen, people, just so you know. That's
all of the fees from it go directly to the Fred Hollows Foundation, so there's no commercial interest involved.
So the question I have is, how do we, as machine learning practitioners, make sure that the obvious breakthroughs that we're currently making, that's going to cause some dramatic economical problems in the next 5 to 10 years, don't really stifle and slow down our progress? Because policy will come into play the moment you get rid of 2 to 5 million jobs in the U.S. when it comes to truck drivers and possibly taxi owners and all these other jobs. So I'd love to talk about that a little bit.
Yeah, I sat on a panel with a guy from Uber a couple of weeks ago, and he was asked that question. He didn't really answer it direct, but he did say, we find it interesting that we were critiqued when we were creating all these jobs, and now we're being critiqued that we're going to take them away at some point. The real answer I truly believe in, and I'll open up to you guys, I think the amount of productivity we're going to create in the entire economy is going to change a lot. I think when we look at what's going to change in healthcare, I think it's going to change people's insurance. We've been trying to solve insurance in the United States. I think AI is going to do it for us over time, where we're going to be better predictive. If you sign up to be a good driver, that's an AI problem right now, right? They're actually tracking all that data, but how we clean it, how we actually determine whether it's going is happening. So if you start thinking about the production of food, we talked about anomalies. Weeds growing in your crops or some parasite on your crop that can be detected by image recognition of drones flying over it, and then you know which areas to go after is important.
In fact, there's a company doing that with spraying liquid nitrogen automatically based on a video analysis, and it dramatically improves crop yields, and it also avoids the need to use pesticides, so it's organic.
So if you think about all the productivity gains we're going to be experiencing, I'm bullish.
I do think it's good to share this knowledge. So if you have knowledge of AI or how to build this technology, it's good to share it. It's better when more people have this technology than fewer.
Having said that, sorry,
go ahead, Jeremy.
I was going to say, we've been talking about this at Singularity for years, and everybody I'm aware of on the faculty now believes in a basic guaranteed income as being a step we will need to take. We are all convinced that, as far as I'm aware, I don't know anybody in the faculty who feels otherwise, that over half of the jobs will disappear and will not be replaced by anything we would currently recognize as jobs, and that will only increase. And so a transition going through a negative income tax and then to a basic income guarantee will be necessary over the next N years. I don't think I'm prepared, or anybody is prepared to say how long N is, but I think we need to be kind of culturally ready to accept this idea.
Yeah, I was going to second that. I mean, the
One here
social
with the
impacts are
microphone.
gonna be huge.
So again, I'm Masood from Huawei. So when Turing wrote his paper, 1950 paper, and he launched AI, he was smart enough to just pose a test. He didn't say what AI was, how to build the systems. He just said, this is a test. People went and did research, and they believed they could represent the world, and if they represented the world and had enough rules, they'll be able to solve problems. So we had things like Doug Leonard's Psych, we had the research at MIT, etc. And then philosophers critiqued this, said, we act intelligently in the world, not by representing it, we just behave intelligently because we're built for the world. There was some argument like that. And then people started looking at pattern recognition. It was important, neural networks. It allows us to kind of recognize patterns without having to explain them. In fact, that's the beauty of neural networks, I would argue. So moving forward, if we take this idea that the world actually represents itself for the cognitive agent, and look at the way I'm going to go to a question regarding cars, the auto-driving cars. Imagine what happened when we went from horses to cars. Horses accommodated to cars, and then cars changed the environment we lived in. We have roads, suburbs, signs, lanes that make it easier for human being, not the horse, to be driving, sitting in the machine and driving it using our cognitive brain. So the question I have is this. Why is it, do you guys believe that we can have autonomous driving without transforming our cities, our roads, our infrastructure to support this new cognitive agent that's about to be born?
We shouldn't. Right? I know one of the, there's a fascinating bit of research from a guy at Singularity called Brad Templeton, who shows how, he calls them robocars. He used to work on the Google team. Robocars can reduce pollution by a long, long way. It's less polluting than even the most efficient Tokyo trains at peak hour. But to get there, we need to be doing things like, we'd have a bunch of cars. Almost nobody would own one. They'll be circulating all the time. It'll be kind of more like Uber. There would be no need for parking on the whole, because why would you park something that's just circulating around? That'll be a totally different infrastructure to take advantage of that.
I also think this is sort of a question about the nature of change, and it's not so clean like that. It's not like this changes then that or that changes then. It's a interplay. So as the self-driving cars get better, then certain other things will change, and then once those things change, they'll impact the way self-driving cars change, so on and so forth, and that's how change unfolds.
Yeah, I think it's important to remember all the examples you gave in self-drive. That's detection, right? So that part we're pretty good at right now. If you listen to Jan LeCun or some of the other people talking about the common sense aspect of next, perception and how you make the decisions, that's really what the industry is working on now. So it's a couple years.
My understanding, though, is he's talking about the changes in infrastructure that happened when the horse changed to the car, and indeed when the horse changed to the car, for a while cars were considered wildly out of control and totally inappropriate for the environment in which they lived, and that was because they lived in an environment that was built for the horse. Yes. We may well see the same thing with self-driving cars for a while.
First thing, we'll get rid of the mirrors because they're not useful anymore. But anyway, let's go on.
They're legally required, and so is the steering wheel. Legally required.
At some point, the
because
mirrors
of
are
regulation. That'll take 10 years.
They're drag on wind and increase.
I think it's also going back to how the enterprise have to prepare for the change. Yeah, how in every role, how digitalization and all this will change how a person works, and so that itself is something that we are preparing for as well, to have that sort of conversation. Because you need to work with new cities, you need to work with making sure the workforce that comes in is quite appropriate to think that way.
So, wow, that's louder than I thought it would be. So, I grew up in the passenger seat of an 18-wheeler. So, when I was a kid, my dad started a trucking company, and now he has a number of drivers, over 10 at this point. Every summer, until I graduated high school, I sat in the passenger seat of that truck and saw how that industry has been for the past 50 years. And last summer, I sat down with my dad and all of his drivers, and we talked about what would happen upon the introduction of autonomous fleets. And they're incredibly apathetic. They do not even retraining. They do not believe that there will be a transition. They think that legislation will step in and save them. This is the belief of every truck driver in America today. My issue is training can help, but I do believe that it's more about empowering drivers and changing the conversation around what is possible for someone who fills that role in society. I talk to my dad and I say that it's not that your drivers will not be useful. They are not the useless class of people. I don't think that's fair to call anyone a useless in the useless class. So if a driver can manage one truck, with autonomous driving, he can probably manage 5 trucks, which means we can have 5 times speeds, like five multiples in productivity of autonomous fleets. Do you think we're thinking about productivity of these people appropriately?
Well, I'll point out, I think when most people are talking about autonomous driving vehicles, there's completely autonomous, but then there's the idea that it's actually assisted driving. It's like there's still pilots on planes. So I don't think the transition is going to be falling off. One day we're going to say, pull all the drivers out. There'll be assisted driving, and there'll be various levels of assisted driving. Like maybe during this stretch of road, we won't need the driver to be active, but there'll be some other components as you're pulling into the city or some other interactions that you will need. So it's not going to be a complete cutoff. Think about the toll booth, right? I mean, we talked about that. That was going to go away for years, and slowly but surely it is. Fast Track will replace those people, but there's still some interaction that is required that's going on there.
Often when technology is introduced, the expectations around the output of that technology are raised. So I think video production is a great example. When producing video was very expensive, then our expectations of production quality were quite low. As video production has gotten cheaper and cheaper, our expectations get higher and higher. And I'm inherently an optimistic person. I believe that that this technology will raise that bar, and that lots of people will be able to participate, and we'll be able to see things that we can't even imagine right now, both in terms of what people are managing and in terms of what people are creating.
I think we're down to our final moment. Do we have time for one more question? We do. In the back of the room there.
Hi, I'm founder of Lacrea's Complexity Production Company, and we're currently addressing homelessness. In LA, we're trying to integrate AI into a new community model that's ameliorating the 78% affected by any kind of mental issues. I'm actually just really curious about the panel's opinion on how this kind of machine learning can be used. Sorry, I'm really nervous. It really goes into relation of the nature of change. And I'm curious what your opinion is on the social implications and how this might be seen as a way to stimulate empathy and social movement around these unsolvable problems.
I think that's an amazing question, and thank you for working on what you're working on. I think it is something that, I don't know, offline we would love to follow up on, because I think it's a worthwhile thing that you're doing there. As far as how you address
offline
it.
Also, one of our students is working on applying deep learning to mental health issues, so I can help put you in touch with her. You guys, I'm sure, could talk.
So, what about wrap up? Last thoughts, you guys? Maybe we'll start with our esteemed guest from Shell.
I think as an enterprise, we all know this is the future. And we have to address a lot of issues, be it the social issue, the regulations, and even the natural human issues that needs to get there. It's not something that you can stop. It's not something that says that you should participate in. Like what you said, it's something that just needs to be done, but you do it with a great consciousness of what do you want to achieve out of that. So to us, it's a critical issue, and we continue to work with academians and other industry to see how we can make this world a better world with giving energy to more and the higher populations that we are expecting.
On that topic, I would say, since I don't know if there's anybody else here from academia, but plenty of folks from industry. please realize that on the whole, academia is not working on the things you care about and do not understand the things you care about. So if you want them addressed, you're going to have to do it yourself. In order to do it yourself, the way to do that is to invest in your people. I have again and again seen companies, particularly larger companies, underappreciate their technical staff. They fail to put them into management positions. They fail to listen to them, most of all. I like what he's now the CTO of the United States, DJ Patel, talked about creating your Spock in Star Trek. You know, Captain Kirk always listened to Spock, the data-driven guy, because over time he realized again and again Spock gave good advice, despite the fact he didn't understand any of the human stuff that Kirk did. Often your Spock will be somebody you don't feel a great connection to, you don't really know where they're coming from, but they're going to be giving you the right answer. And so rather than bringing in some outside academic or some consultants or some whatever piece of software, unless of course it's Bonsai, invest in upskilling your people and on listening to them.
Once you get the plug, you might as well go next.
Sure. I mean, I think that for those of us in the data scientist community or in the AI community, we have a responsibility to enable people. Enable them through education, enable them through better products, to really make sure that everyone that we can use and take advantage of this technology, so it's not just a small group of people that use it.
Yeah. And there's, by the way, there's plenty of platforms for people to advance. You can go to any major service provider and get access to the infrastructure you need. More and more, it's accessible. So, and I think it's great that we have people after training great students to do this kind of stuff.
Yes, me too.
So, Todd, until we get there.
I mean, I just think it's an exciting time to be alive. People have talked about AI for a long time, since Turing or longer. And, I feel like we're actually at the precipice of a big, big change. And, you think back to the PC revolution and, people thought it would be tremendously economically disruptive in a good way. And actually, it's not borne out that much. People have PCs, people have mobile, but, GDP per capita didn't really go up in the long-term trend that much. I think this is going to be very different. It's going to transform economies. It's going to save lives. And it's also a little scary, of course, because there's going to be a huge amount of disruption. And I think, and with you, Jeremy, that we have to address that.
Andrew Ng calls it the new electricity. It's not the new internet, it's new electricity, both in terms of the impact on society and the impact on the economy. And I think he's right.
Awesome. Well, with that, Karen, we'll give it back to you. Thank you so much for this forum.
Thank you very much for everybody for sharing your views so candidly. We really appreciate it, and great audience participation. Appreciate that as well. As a very small gift for our speakers on the stage this morning, we do have for each of you a Churchill Club speaker T-shirt.
All right. Nice.
Lunch, which is available in the foyer, and the breakout sessions, which are happening in this room, will commence now. And we hope that each of you will participate, enjoy lunch, and continue to contribute your thoughts and ideas and questions to the discussions. The three breakouts are machine learning, deep learning, which will be in the very back, led by Jim or one of his Nvidia colleagues. Accelerated compute platform, right there in the middle, which will be led by Keen. And enterprise-ready AI over there, which will be led by Todd. A recording of this program will be available on our YouTube channel within the next probably 3 days. So you will also find recordings of our other things there. We hope you'll find them useful. And that's a wrap. Thank you. Enjoy the rest of your day.